right, so we did adding, subtracting, and multiplying complex numbers. Now we are dealing with division of them. So 28, 7i over 8 plus I. So big thing is I can't ever have an I left on the bottom. Okay, so I need to multiply by what we call the complex conjugate of the bottom to get rid of it. I's on top are okay, I's on the bottom are not okay. So the complex conjugate would be 8 minus I. Anybody know why that would be the case?
Because they're opposites.
You're like getting rid of the other one.
Because you're getting rid of the I.
Yeah.
I don't know.
What are these?
Opposites.
Difference of squares.
What is a difference of square?
We learned that last.
The thing that we learned in 4.3.
Yeah, and I got like a 50 on that quiz.
That's kind of sad.
I don't know. When two squares are subtracted.
See how in the first one it has a plus sign and then the second one it has a subtraction sign?
Yeah.
But the other two numbers are the same?
Yeah.
That makes it the difference of squares.
So where's the square?
You're
Where did the-
multiplying them by each other.
Where did the 7 go?
Think 25 minus x squared. That's a difference.
It's
of 2
gone
squares.
nowhere. It's still right
It's
here.
5
I'm
squared is
multiplying.
25,
Oh, but you're multiplying by that. Okay.
Right.
So what is 25 minus x squared?
So 25 minus x squared is factored to 5 plus x times 5 minus x. Right?
Right.
Okay, moving on. On top, I get 56i minus 7i squared over on the bottom. Shepherd, what do I get?
16!
No.
64.
Multiply. 64.
That was close.
That's not it.
Negative
Plus.
I squared.
Okay, you're multiplying.
Minus I.
Negative
Squared.
I squared.
Minus I squared.
I thought it could have been above. Because I squared is -1.
So I squared is -1. This is negative, so this is going to be plus 1.
65.
Negative 7i squared would be...
7.
7.
Yep, so this is going to be plus 7. So I need to write this in standard form. Okay, and it's split into two pieces because standard form is a plus bi. So I get 7 over 65 plus 56 over 65i.
Why would it not be? Never mind. Wait, what? Why isn't it 56i over 65?
Has to look like that.
But why is the... Oh, it's because the I is next to the 56, so that makes it the B term instead of the...
Yes.
Okay.
Yeah, whatever I is touching is B.
Coach.
No. It's my 67 for Spanish.
And I got a 90 on.
Don't tell about passing
All right, 30. -2 minus 5i over 3i. So this one is a little bit different, okay? The first one we had 8 plus I, so to get rid of it, we needed to do a difference of squares. This one I only have 3i on the bottom, and I need to get rid of I. So,
Divide by I.
any idea what I might need to do?
Idea.
Multiply by I.
Multiply by I,
Yup.
top and bottom. When I do that, I get,
Shouldn't it be negative I?
no, -2i minus 5i squared over 3i squared. 3i squared is what?
3i squared.
Negative.
-3.
-3.
Done.
-5i squared is plus 5. So I get -5 over 3. This is, both of these are negative, so plus 2 over 3i. And just, we haven't had one that would reduce yet, but if we ended up with anything that the fraction would reduce, we would need to be reducing.
Bless you.
Does the negative from the negative 2i just disappear?
Nope, negative 2i over negative 3 would be positive.
Oh, right, positive. Sorry. I was
Yep, get it back.
Creme brulee.
32. 7 plus 4i over 2 minus 3i. What would I need to multiply this one by?
2 plus 3i.
So we're multiplying by the complex conjugate. On top, what do I get?
You get 14 plus 12i squared.
No. Foil.
21i 8
Guys, it's boiling.
alpha?
It's not
No. I
Sorry,
forgot the
it's
squared.
12i
I forgot the squared I.
Yep, 12i squared.
there. It's not
Over. The bottom's the difference of squares. What do I get?
You get 2, and then
4 minus
You get
I
4.
squared. 9i squared.
oh man.
4 minus 9i squared.
It's not that hard.
Alright. 12i squared is
Negative
Negative
12.
negative 12. Negative 9i squared is.
9 positive 9 plus 9.
Yep. So I'm going to rewrite this one first before I split it because I have extra stuff going on. So 14 minus 12 is 2 plus 29i over 13. So now I'm going to split it. So 2 over 13 plus 29 over 13 times I. And you can do all of them like by reordering it over one fraction and then split them, but I usually just try to do it one step. So
How come the I goes to the side of the fraction instead of the 29?
anybody want to enlighten
I
Zach?
can do it. So when you're writing it in standard form, it's a plus bi, and your b is going to be the 29 over 13, so you put the I outside of it because it's what the standard form is.
Okay. Anything in my bag, man?
Because it smells good.
I don't know what's wrong with this mask.
All right, I'm going to have you try this one on your own, and then we'll go over it, and there's a little bit more in this section, but this is the last one of this type. Negative 1 minus 6i over 5 plus 9i.
I know how to do this one.
There you go.
Yes, I do. You do 5 minus
You're doing it on your own paper. Do we have an answer yet?
Yes.
All right, what do we get?
I'm afraid to say. This doesn't-
Mine also does.
It looks weird.
Negative 59 over 106 plus negative. I mean, minus 21 over 106i.
Oh my goodness.
Do we agree,
I
disagree?
did not
I
get that.
disagree.
Hey,
What'd
I
you
agree
get?
with Daniel. You only
I
said
have 59 over 56 plus 21 over 56. But I also don't think that's right.
How did you get 56?
80. Wait. Give me two more. That's a lot. Well, Daniel.
Does anybody else have
it's
anything
96,
different?
not 100.
Oh, yeah.
Oh, I
It's
subtracted instead of adding. That's
Totally.
why.
Oh, I did that too.
I still got 106.
There we go.
Yeah, it's still.
Oh, it's still
crazy.
106.
It's 106.
So it's negative
Yeah.
59.
All right, so we multiplied by the complex conjugate. On top, we foiled.
Did everyone get that?
On top, we foiled. And we get negative 5 plus 9i minus 30i plus 54i squared. The 54i squared turns into negative 54. On the bottom, we have a difference of squares, so 25 minus 81i squared. Negative 81i squared turns into a positive 81. Combine like terms, you get negative 59 minus 21i over 106, and then we split it up to be in a plus bi form. If you did something wrong, do you see where you went wrong?
Good thing I didn't do anything wrong. Whoa.
All right, the next thing we're doing is graphing numbers in a complex plane. So we are graphing complex numbers.
Yay.
I did this stuff over the summer. It's pretty.
All right, we're going to do one graph here, and we're going to put all the numbers on the same graph. So the x-axis is our real axis. The y-axis is the imaginary axis.
Is that always like that or only when we're doing these funky problems?
Do you think you would have graphed forever and just be finding out that y is imaginary?
Well, we found out that subtraction's not real, and neither is multiple or division.
Right.
When do we have imaginary numbers?
It would be that. When you have an eye.
When I have an eye.
Curvy.
Do you normally have an eye?
Yes. Well, it
Yeah.
depends.
In the alphabet.
Cool.
When have
No,
had
you
an
do
eye
not.
Up to this section, Zach.
In the alphabet.
That's not even an I, it's a backwards
It's not.
J.
We haven't used that before.
Ryan, I'm about to break its back.
All right, so the x-axis, this is 1. The y is I. This is negative 1, and this is negative I down here. Okay, just for reference. So I'm going to write down the problems. 34 is 1 plus 2i. 36 is negative 6i. 38 is a negative 7 minus I, and 40 is 7. Realizing my graph is not big enough. Okay. All right, so the way we do this is we find the spot.
Bless you.
The real part tells us if we're going where we're going on the x-axis. The imaginary part tells us where we're going on the y. So this 1 plus 2i, we go to 1 on the real, and then 2i, so we go up to. So this is problem 34 right here. 1 plus 2i.
34.
It's problem 34.
Oh, okay.
Yeah, I was confused too.
And when I give you these problems in your homework, you can do the same thing. Just plot them all on one graph. You don't need to make 4 separate graphs to do them.
So. Okay. Okay.
All right, 36 is just negative 6i. Okay, so if you need to think about it, this is like 0 minus 6i. Okay, so 0 on the real. So that means that this point is going to be on the y-axis at negative 6i. So all the way down here, this is problem 36.
This is way easy.
Yeah, this isn't hard. I was thinking it was going
Yeah.
to be hard.
It's actually really hard.
It definitely seems like it could be really hard, and then it's super easy. And people are always like, oh no, and then I'm like, it's literally just plotting points.
Yeah, it's not even making a line.
No, they're not.
Ugh.
Alright, negative 7 minus I. So I go to negative 7 on the real. And then minus I, so down 1. And that's problem 38. And then problem 40 is just 7, so that just means I go to 7 on the real.
If it was 7 minus I squared, would it be?
They're not going
On
to give you
8?
that.
Oh, you can't do that.
I mean, they're not going to give you that, but yes, that would be the case. So that's problem 40. All right, the last thing in this section is the absolute value of a complex number. Did you have that in your notes?
No.
Oh, yeah,
Maybe.
how does it
No? Okay.
Say?
Then I need to write these notes down really quick.
What did she say?
All right, absolute value of a complex number.
Of course you do. It's not good.
I love games.
I don't get what people see in.
All right, z equals a plus bi. The absolute value of z is a non-negative real number defined as the absolute value of z equals the square root of a squared plus b squared. What does that kind of look like?
Quadratic formula.
Intercepts of a non-negative real number.
Y'all took geometry last year, right?
Yes, yes,
We
we
had
did.
a postulate book.
Oh no, what's it called?
A squared
What's it
plus
called?
B squared
Distance
equals C
formula.
squared.
Distance formula.
Yes, what is that?
Pythagorean.
Pythagorean theorem.
Pythagorean theorem.
That looks just like it.
It's Python.
What's it Pythagorean?
Well, where's the z squared? Oh, because you gotta take the square root of
I-
it.
There's no.
I'll show you where I'm getting the triangle from in a second. Let me finish
Triangle.
writing this. This is this is the distance
Where did we bring triangles into?
between z and the origin in the complex plane. All right, so I have this here, which is the absolute value of z equals the square root of a squared plus b squared. The real part is here, hence why we do this after we have graphed these. This is a, which is the real part. Going up here, this is bi, which is imaginary.
It
Now
is a
there's your
triangle.
right triangle.
So the absolute value of z is slope.
Break his back.
It's the hypotenuse.
A pun.
Trig's gonna be fun in a couple months.
So fun.
Can I ask a question?
Yes.
So, can't the square root of a squared plus b squared just be reduced to a plus b?
No cap.
No.
No?
Why not?
Because it's a sum of the two numbers.
Yeah.
Okay.
And then
Oh, yeah, okay, I got it.
All right. So
So the square root of a squared plus b squared is not
Oh,
the
about
same
that.
as the square root of a squared plus the square root of b squared.
correct.
Okay.
Transform.
But
You
wait,
can't add them
It's a boat.
because they're different.
It's a boat.
a chunk, dude.
Oh, because when you square it, if it's negative, it could be.
You can't have
Okay,
every
okay,
negative
okay.
number. That's the magic.
No.
It's
Because
like a
if a equals -1, then it doesn't work to just add it. Okay, that makes sense. This makes sense.
It does make sense.
All right, 4 plus 3i is the problem. It says find the absolute value of the complex number. So I'm going to put absolute value bars on it. That's equal to the square root of a is 4, so 4 squared, plus b is 3, so 3 squared. What's 4 squared plus 3 squared?
16 plus 9 is 25.
Square root of 25 is
5.
5. Weird 5. And that's your answer.
It took a lot out of me to do that. So, okay.
So when we
So Z is our problem, right? Z is the 4 plus 3i.
So now we know.
Yes.
Yeah. So now we know that 4 plus 3i equals 5. So now do we, like, the problem is solved? We don't have to do anything else with that?
Yeah, that's it.
Okay.
That's the absolute value.
Oh, I
Which
thought
would
it
be
was-
the distance between the origin and Z.
Oh.
Okay.
Okay.
This is like a distance formula for complex numbers, kind of.
Will we have to be doing
I
like
hate
a
my
little
cats.
line graph like
Alright,
that?
8
No,
for
I just did that
cats.
as a visual
Okay.
for you to see what's happening.
Okay,
I didn't
thank
even
you.
touch him today and I got thrown.
All right,
This is what the big guy did to me yesterday.
44.
Mom.
10 minus 7i.
Kelvin?
So we're taking the absolute value of it, square root of 10 squared, plus, now notice, 7 is negative,
But
so
it's
negative
positive.
7 squared. So yes, it's going to stay positive. So this is the square root of what?
149.
149.
Which is
No, it's not 13.
7 and 5.
It's not 13, never mind.
35.
pregnant.
It's what?
35.
Preg. Huh? What, Jeannie?
So,
All right,
That means
what
I'm-
if I have this one, 46, negative 8i? Whoa.
whoa. That's not allowed.
Yes, you can.
Oh, it's just
It's
gonna be
just 8.
8.
Oh yeah, because the distance is 8.
No cat.
Yep, because 0 is a, so that would just be like 0 plus negative 8 squared, which would just be 8. That would be the square root of 64, which is just 8. So if a piece is missing, you just put in a 0 for it. All right, any questions?
I'm with my dogs.
All right, your problems then are
Wait, hold up.
Whoa.
29, 31. The graphing ones are all able to be put together, 35, 37, 39, and 41. So you just need to draw one plane and do them. And then 43, 49,
Guys, if we finish our homework really
and I want you to do 53 also.
quick, I'm not this.
Shouldn't it be positive 64 instead of 8? Because of,
The square root of 64 is 8.
Yeah. Get that smirk off your
All right, so just add these to the problems that you already had. There's no notes for tomorrow, so
Oh, we're just
Oh, then why did I
also
write
it's
it down?
Wednesday, so if you don't finish these, obviously not due till Friday, but
I was afraid about the cut.
Oh, Jeannie's graph.
The cut.
yes. I just lumped those together so that you would see what, is happening.
Good.